Good morning students. Today we will study what is LPG, what is CNG, what is cetane number and also free radical mechanism of chlorination of methane. LPG, liquefied petroleum gas. It is a colorless, odorless gas. It can be liquefied under moderate pressure. It is a mixture of 40% propane and 60% butane. It is 15 times heavier than it is used as domestic fuel. The fuel which we are using in the gas in our houses, this is the LPG. Caloric value of LPG is 1,80,000 kilocalorie per kg. So LPG is liquefied petroleum gas. It is colorless, odorless gas. It is can be liquefied under moderate pressure. So it is a mixture of what? Propane and butane. It is heavier than air. And its calorific value is 10800 kilocalorie per kg. What is CNG? CNG is produced by compressing natural gas to less than 1% of its volume at standard atmospheric pressure. To provide adequate driving range, CNG is stored on board in vehicle in a compressed gas state at a pressure of up to 3600 pounds per square. CNG is used in light, medium and heavy duty applications. CNG is composed of, it consists of methane gas, which like gasoline produces engine power when mixed with air and fed into your engine's combustion chamber. When CNG reaches the combustion chamber, it mixes with air. So what is happening? It is mixing with air, is ignited by a spark and the energy from the explosion moves the vehicle, due to which the vehicle moves. Why is CNG preferred over LPG? CNG is preferred over LPG because it produces greenhouse gases upon combustion. It is a more environmentally clean alternative to other fossil fuel like gasoline or LPG. So it is why it is preferred, because it produces greenhouse gases. Greenhouse gases means water vapor, CO2, methane gases are the greenhouse gases. So it is preferred because it produces greenhouse gases in place of LPG. Then what is cetane number? It is an indicator of the combustion speed of diesel fuel and compression needed for ignition. It plays a similar role for diesel as octane rating does for gasoline. This definition I have taken from net. So cetane number is an indicator of the combustion speed of diesel fuel and the compression needed for ignition. It plays a similar role for diesel as octane number is there, just like that it is cetane number. The cetane number is an indicator of ignitionability of diesel fuel. It provides information upon ignition delay, that is the speed of self-ignition of diesel fuel when injected into hot air to the fuel injector. Pure cetane is assigned the highest cetane number, that is 100. This is the most ignitable and pure. 1-methyl naphthalene, the lowest cetane number 0. Least ignition. The cetane number describes the percentage of cetane found in the mixture that correspond to the ignition quality of the fuel. Test fuel. So the percentage will decide how much pure that is. The pure cetane having highest cetane number is good, that is having ignition 100, and 1-methyl naphthalene has a lower cetane number of 0. Octane number. This is a measuring term used to measure knocking quality of an automobile fuel. In modern gasoline engine, under certain conditions, the smooth explosion of the fuel-air mixture, this cylinder is replaced by knocking quality of an automobile fuel. The relative identity-knock tendency of fuel is indicated by its octane number. So, quality of the fuel is indicated by the octane number. For example, N-heptane with octane number 0 knocks very badly. So N-heptane is not a good fuel because it has cetane number 0. And isooctane with octane number 100 is a better fuel because its octane number is 100, is a good fuel. Greater the octane number, better is the quality of a fuel. So the cetane number will decide the quality of the fuel. Mechanism of free radical halogenation of methane. So here we are studying the chlorination of methane, which gives chloroalkane. When methane is treated with chlorine in presence of UV light, chloroalkanes are formed through free radical mechanism. Hence the mechanism is called as free radical. So when this is happening, the free radical is taking place, and so it is known as free radical mechanism. Free radical are the species having single or odd electron are known as free radical. The free radical mechanism proceeds through the following steps. So there are three steps: chain initiation, chain propagation and chain termination. The first step is chain initiation. Here in the chain initiation, the free radicals are produced. Chlorine molecule on heating or irradiation of ultraviolet light undergo homolytic fusion to give free radicals. Chlorine molecule, Cl2 molecule in the by UV light homolysis or homolytic fusion takes place to give two chlorine free radicals. This is the first step, chain initiation. Next is chain propagation. Next step is chain propagation. First one chain initiation, second is chain propagation, third is chain termination. In the chain initiation reaction, we have seen the free radicals are produced. In the chain propagation, in this step, free radicals so form reacts with methane and produce methyl free radical. So methane in the presence of chlorine free radical will give methyl free radical. And methyl free radical in turn abstract chlorine atom from the molecule. It will extract chlorine atom from the molecule, this one, of chlorine, and produce chlorine free radical. So it is abstracting one chlorine atom and forming methyl chloride. Chlorine free radical is released. In the same way, this chlorine free radical again combines with this to give CH2Cl, then HCl, then CH2Cl plus Cl2. We are getting CH2Cl2, dichloromethane. This dichloromethane again combines with chlorine free radical to give CHCl2. Then CHCl2 again with chlorine, abstract one chlorine atom and you are getting CHCl3, chloroform and chlorine free radical. This chlorine free radical again with CHCl3 will give CCl3 plus HCl. This CCl3 again abstract one chlorine atom and you are getting CCl4, chlorine tetrachloride, carbon tetrachloride and chlorine free radical generation. This is the chain propagation, means chain goes on increasing in this reaction, in chain propagation reaction. Next, chain termination. In this step, two free radicals combine to stop the chain reaction. Hence, this step is called as chain termination. The chain ends in this here, in this step. So, this is known as chain termination, means ending of the reaction. Chlorine free radical plus chlorine free radical will give chlorine molecule. Chlorine free radical and methyl free radical will give CH3Cl, methyl chloride. CH3 free radical and CH3 free, methyl free radical will give ethane. In this way, all the free radicals which are free there, they combine to give different types of different molecules as a whole. They are given. Thank you.